In this, we can see about section modulus. So, section modulus. So section modulus means it is the beam strength, or we can see how strong the beam is, or how can a beam resist the moment and resistance. So this is what section modulus. So if I am having what high section, circular section, rectangular section. So if I want to know that which is stronger, which one is stronger, for knowing that, what I want to do is I want to calculate the section modulus of all this. Then we can see which is more strong. So while designing this, maximize the strength. To get this maximum stress, what we want to do is section modulus should be what? Maximum. Okay, so first we can find out this section modulus of various beam cross section. So section modulus Z equal to what? I divided by moment of inertia divided by Y max. First note down this, it's very important. So Z equal to I divided by Y max. So first we can see about this rectangular. For the rectangular cross section, this is rectangular cross section. So it is having what? This is x, and okay, so it is having what? It is having both section modulus. I will just note down. So it is having both section modulus, that is section modulus at y-axis and section modulus at x-axis. So for that, if it is, this is h and this is b, then what is section modulus? Section modulus is I divided by this y max. Y max means exactly half, that is h by 2. While considering this z1, that is at this z1 means what? I am considering here it is breadth and here it is. So we will be getting I is what? bh cube divided by 12 divided by y max is h by 2. That is h divided by 2. So while solving we get bh square divided by 6. And for the z2, it will be like z2, it will be this is dominant, that is I is what? I is hb cube divided by 12. So this is I divided by what? Divided by this h by 2. So z2 equal to this is hb square divided by 6. Next, if it's for the circular section, next is z equal to, that is I is what? Pi d raised to 4 divided by 64 divided by this, that is y max is y by 2, that is d by 2, that is what it will be? D by 2. So we'll be getting this pi d raised to 3 divided by 32. So rectangle bh cube divided by bh square divided by 6, and z2 for this rectangle is hb square divided by 6, and for the circle it is what? Pi d cube divided by z2. So do you remember that sigma max for this rectangle? Sigma max for this rectangle is 32 m divided by what? 32 m divided by pi d cube. That is for the sigma max for this, for the circle. And for sigma max for this rectangle is sigma max for the rectangle is 6m divided by bh square. Okay, just compare that 6m divided by bh square for the rectangle sigma max. And if I'm having square, then it will be AA. Next, what will be z? Z equal to I, what? I equal to, that is no bh cube and all. Here it will be b raised to 4 only I, and y max is nothing, a divided by 2. So while solving we get b cube divided by 6. Next, for the triangle. For triangle, from this portion, if this is neutral axis, then here it is 2h divided by 3. Okay, here it is 2h divided by 3. If it is whole height, then if we find from this point, it is 2h by 3. This will be the maximum. So so moment of inertia of this triangle is what? bh cube divided by 36. bh cube divided by 36. bh cube divided by 36 divided by 2h divided by 3. So what we will be getting is what? Z equal to, so Z equal to, what will be getting is bh square divided by 24. So bh square divided by this 24. Okay, so this is set for this what? Triangle. Okay, so bh square divided by this 24. Next, for this rhombus. So rhombus, this is very important. Very important. For the rhombus, it is having the side b. Then here it will be b by root 2. So here it will be b by root 2. That is by Pythagoras theorem we are solving, and we get this as b by root 2. Next, z equal to, for this rhombus it is b raised to 4 divided by 12. For this square it is b cube divided by 6. It is b raised to 4 divided by 12 divided by what? Divided by b by root 2. So this is what? Y max. So we get the z as b cube divided by 6 root 2. Okay, so we can just conclude all sections and with the different moment of inertia, so that it will be easy for solving. So we can find them first. We can just see the moment of inertia for this rectangle. It is moment of inertia, rectangle moment of inertia equal to bh cube divided by 12, or hb cube divided by 12. For circle, moment of inertia equal to pi d raised to 4 divided by 64. Pi d raised to 4 divided by 64. Next, next we can see about this square. This is square. Okay, not rectangle. It's square. Consider it a square. And here it is. Here we can have the moment of inertia as b cube divided by 6. And for the rhombus, the z equal to b raised to 4 divided by 12. So just compare this and extra b will be added. Okay, so and next what section remaining. Next, for this triangle, for triangle moment of inertia equal to bh cube divided by 36. Just here bh cube divided by 12, here bh cube divided by 36. For the circles, I equal to what? I equal to pi d cube divided by pi d raised to 4 divided by 64. And we can just write about the sigma max also. So we can just write about the sigma max. So we can just compare. So sigma max of rectangle equal to 6m divided by this bh square. And for circle, sigma max for the circle equal to 32m divided by pi d raised to 3. So this all of this important, because sigma max of this rectangle equal to, it is 6m divided by bh square, and for what? For circle it is what? 32m divided by this pi d raised to 3. And we have just find this section moment of inertia. Next we can just see the section modulus. We can just remember. Okay, next z. So z of area section. First this is rectangle. Z equal to bh square divided by 6. Bh square divided by 6. So the z equal to hb square divided by 6. Next for circle, z equal to pi d cube divided by 32. Here pi d raised to 4 divided by 65. Here pi d cube divided by 32. Here hb cube divided by 12. Here hb square divided by 6. Here. Okay, just you can compare this and study. And for this triangle, it is z equal to what? Z equal to, for the triangle it is bh square divided by 24. Triangle it is bh cube divided by 36. Here bh square divided by 24. And for the square, z equal to what? Z equal to, it is I had any mistake. Sorry, here for the okay, for here for I equal to b raised to 3 is divided by 6 is z. Just substitute instead of h. We want to substitute this b. So b raised to 4 divided by 12. So b raised to 4 divided by 12. So that's all for the psi. And for the rhombus. So rhombus, it will be, so here I am just splitting that. Okay, we can see for the for square it is z equal to b cube divided by 6. I think everything is over. Next rhombus, z equal to b cube divided by 6 root 2. B raised to 4 divided by 12 is I, and here z equal to b cube divided by 6 root 2. So if we can see a question. So they are finding the section modulus. Okay, here it is b and h. Here it is total is what? D depth, and inside it is d. So what is I? So I is nothing but this pi by 64 into d raised to 4 minus d raised to 4. That is small capital D divided by small d divided. This is I, and y max is what? This is I, and y max equal to this d by 2. So by substituting section modulus, that is I divided by y max, what we will be getting is, while solving this 2, I am getting z equal to pi by 32d into d raised to 4 minus d raised to 4. So instead of this, I can write it as what? I can write, or I can just form a, that is, you can just assume k equal to small d divided by this, that is inner diameter, inner dia divided by this outer dia, outer dia. So we get this z equal to pi by 32 d raised to 3 into 1 as k raised to 4. So k equal to small d divided by capital D. Just I am having two section. I am having, this is of this different material. This is of different material, and this is of the same material. Okay. So here what happened is sigma 1 equal to what? Sigma 2 allowable. So sigma 1 allowable equal to sigma 12 allowable. So what I will get is m1 equal to sigma 1 z1, m2 equal to sigma 2 z2. As these are of same material, then both get cancelled. So I will be getting m1 by m2 equal to z1 by z2. if for this different material, what will be happening is sigma 1 not equal to sigma 2, both stress it won't be equal, because it is having different material. Then m1 by m2 equal to what? Sigma 1 z1 divided by sigma 2 z2. We can just see for an example about this two example. Like I am having a square and I am having the diameter d. I'm having circle also, so both is having same material, so if it is having same material and I want to find this, both same material, and both area also same, circle also area same. So I want to find the moment of resistance, that is I want to find this moment of actually the question is I want to find this moment of this rectangle divided by moment of the circle. Okay, so how I'm going to find it? So first is I'm just dividing sigma rectangle equal to sigma circle, both having same material. So same material means sigma 1 will be equal to sigma 2. So sigma rectangle equal to sigma, that is sigma of this circle, both having same stress, right? Next, so sigma equal to what? That is, we have already studied, if for these two materials, that is m1 divided by this m2 equal to z1 by z2. So same thing for this rectangle equal to z of this rectangle divided by center of the circle. So z of this rectangle is what? A cube divided by 6, already we have studied. Z of this square is pi by 32 d cube. So while solving, what will we get? The 32 divided by 6 pi into a divided by d whole cube. So we will be getting 16 by 3 by a by d the whole cube. Okay, so but what we'll be getting is 16 by 3 by a by d whole cube. So this is a square equal to, we already know that a square, that is area of this rectangle, equal to area of the circle, that is 5 by 4 d square. What I will be getting? A by d equal to root by divided by 2. So this I am going to substitute here. This I'm just going to substitute here, and what I'll be getting is m rectangle divided by m circle equal to 16 by 3 pi into root, that is instead of a by d I'm going to substitute root pi divided by 2 the whole cube. So after solving m rectangle equal to 1.18 times m. So that's why we are using rectangle. Almost all sections we are using this rectangle because it is more strength, it is having more moment of resistance while comparing to what? While comparing to circular one. Next we can see another problem. So I'm just okay, I'll give you another question. The another question is, I'm having this rectangular and I'm converting it to rhombus. So how much percentage it will get affected? How much percentage for the section modulus it will be affected? Will it be increase or will it be decrease? So let's see. So moment is directly, here it is AA and here it is A, here it is what? Diameter. So moment is directly proportional to Z. So moment of this square equal to moment of this rhombus. So m so it is also equal to set of this rhombus divided, because both are having same materials. So we have already discussed that both having same materials will have this also same. So for this rectangle, what is the set? A cube divided by 6 divided by this a cube divided by this 6 raised to 6 root 2. Okay, so what we will be getting is 1.414, that is root 2. So moment of this rectangle divided by moment of rhombus equal to 1.414. So they have asked about how much percentage it has affected. So to find this percentage of this affected, we are sigma rhombus minus sigma rectangle divided by sigma rectangle. So what we will be getting? Sigma rhombus by sigma rectangle minus, sorry, sigma square minus sigma square divided by sigma square. So sigma rhombus divided by sigma square minus 1. So what I am getting is, I am getting about this, it is here 1. So 1 by root 2 minus 1. I am getting after solving minus 29.27%. So it is getting decreased by this percentage.